Greetings everyone. In the last video, we saw how physical chaos helps us in cryptography and how it helps us to manage our data secure and how this lets us do encryption and decryption. In this topic, we are going to see about quantum fluctuation cryptography because it provides more variations and more details or more amount of data or like more randomness which can be converted into a cryptography or like used later on for encryption and decryption. This will help us or like this will allow us to create so secure channels and also so encrypted and decrypted message that a third party cannot access. Okay, how does the as we know, as we saw in the last video, randomness problem is simple. Randomness is so important for the key generation process. Like the key should be so random that it can't be regenerated or it can be, how to say, like it can't be like accessed and the text or something, the algorithm should not be found out how the key is generated. Such things should not be done. So we use PRNGs usually. So, but we needed a change. We followed physical chaos, which included the lava lamps and bubble tubes. Here, we are using the quantum solution. What does quantum do? As we know, what does quantum say? Light travels in both particle nature and also ray nature. So similarly here, so what it does is, so it creates as a we don't know how the atoms will move or an electron or a simple proton will move. So it is like it is so uncertain that there will be so many changes. The randomness will be high, uncertainty will be high. So it helps us generate a key that is so secure. So that is what's said here. The quantum solution says it is governed by the Heisenberg Uncertainty Principle. That is what more fluctuations occur and the movement of protons and neutrons, electrons are so random and it is spontaneous. So let us go to the next page. Yeah, how does this vacuum fluctuations happen? Quantum vacuum fluctuations happen. So we have the algorithms called quantum random number generators. What does do? This captures the movement of particles, antiparticles, and how it travels in the empty space and how it comes out, how this goes. Everything is captured, and algorithm is used to process the data and give us a number that is so random and that is used for encryption and decryption process, which acts as a secure key. So, what does Heisenberg uncertainty principle do? See, principle like how what does basically Heisenberg uncertainty principle says? Energy and time cannot both be precisely determined because what we do say is like sometimes the energy that proton coming out may be different, sometimes the direction is different, and maybe sometimes it requires a little bit of more intensity, so it will take time. So it is so uncertain, you cannot say at the exact point where the proton will be ejected. So similarly, virtual particles. Particle are and both particle and antiparticle pairs spontaneously emerge from a quantum vacuum. That is simply when an atom is kept and when an intensity of light or something is hit on the atom, there will be an ejection of a proton or an electron that is so random and there will be particle and also a charge, negative charge, positive charge. That's what. There are more number of virtual particles. So these fluctuations are being so unpredictable and also guaranteed by physics. So we use that QRNGs in order to generate a so random number that can be used for encryption and decryption process. Okay. How like vacuum noise or some the fluctuations or the movement of particles are converted into cryptographic keys. Let us simply say a laser, as we know, a laser is passed through a slit or to an electron, which will help us the electron eject. That's the same concept. So let us see. First, there is a laser beam. Okay, that is pointed towards a beam splitter or something, in which there will be an alternate path or like will be a fluctuation of the path that the electrons or the neutron, electron, proton, the atom is following, and also there will be a vacuum. So simply, this is what the whole process, right? In quantum physics. So what is happening? First, a laser is generated, and the laser beam is precisely directed toward a beam splitter. What does a beam splitter do? It splits the beam and it makes them go in different ways. Same happens here. So when a beam splitter takes place, there will be a little amount of photons and electrons, mainly photons, right? Because photons give out light. So photons are ejected. These photons are detected in the site where there will be some kind of detector that detects a heat or a light and gives us how the photon or something is like how the photon or something is received or how it is ejected at what time, at what amount of energy, etc. Now this is then converted into a digitalization. Simply what it is, we give all these data to a hashing function or some sort of function that will compare these with some already preset values, and it will give us a random generation of bits according to the value we got just now, and it is converted into a QRNG, as we saw, quantum cryptographic numbers, right? So like what we get a random numbers. Yeah. So simply quantum random number generation. So simply the key is generated by this. So now this can be used for and perfectly secure for using algorithms like AES, since we got a 64-bit, right? You know how AES works. We pass a chunk of code that is like mostly 64-bit code, which will be used as a key. So it is best for key generation of AES, etc. Since due to its randomness. So how this magic can be measured or something. So measurement itself is probabilistic due to quantum mechanics, ensuring the true randomness that no one, regardless of computer power, no observe. See, even though what they say is simple, even though you get that AES column or something chunk which is so purely random is generated, even if you go give it to someone or somewhere the high processes can be done, it will not even able to find how the key was generated and what was the key and what is the message that is encrypted, because it is so random. It is so random that it would take lot of years or lot of times of beam splitting and photon detection, which is so rare. Okay, which is so rare and not at all possible. So it will take a lot. It is not even possible, and it is so random that help us do. It is so probabilistic, and it has a very minute amount of probability that we can predict the code, the key. So what we can say is this fundamental quantum property being probabilistic will give us a all source of randomness, which will distinguish one QRNG between another, and also ensuring the cryptographic security we use, and also makes the encryption and decryption process more secure. Okay, let us look into what is the difference between quantum fluctuation and physical chaos. As you know, since you saw part one of physical chaos and now we are seeing about quantum fluctuation, let us compare these both. So simply, randomness sources for quantum fluctuation, as we saw, is from vacuum field where a laser beam is passed, right? So in physical chaos, it will be like mostly from a real life scenario. So let us. So what we do is, see, simply it is not at all deterministic. Okay, since like it can happen due when, where, when, at what kind of energy, what kind of speed, we doesn't know anything in quantum fluctuation. While in physical chaos, you know what will happen, how will happen, but you don't know, since it is so random, because like it is not unpredictable, but you'll know what happens, right? But in quantum fluctuation, you does not. And scale, the physical chaos can be observed through human eyes, which we may be able to process, but in a quantum you cannot even see the subatomic particles, so it would be like more complex stuff to make and analyze. So security basis is like for quantum, it is so guaranteed and unpredictable, as the law of physics states, and it got a proof that they are so unpredictable. While in physical chaos, mostly it is because like the thing we focus is like main problem we get is due to the computational measurement, because like the computer has to take in the image or some output that is that it sees, and it needs to convert it into an a PRNG, as we saw. There we use PRNG, and quantum fluctuation we use QRNG. PRNG is a pseudo random number generators, and QRNG is quantum random number generators. While in see, simply what is given, you can see that is physical random number generator and true random number generator. What does this say? True random number generator is really random, and while in physical chaos, it is physical random number. Maybe there is a possibility this will change and that will change. Mostly in classification, like a quantum fluctuation, it won't even, like it is so random, even more than a physical chaos. Both are random, but comparatively, quantum is more random. Okay. Yeah. This is an even though bubble lamps and bubble tubes and lava lamps are an alternative, it is like, yeah, as we saw, we this macroscopic level, and also it also produces a high quality randomness and has lot of affecting factors, so we will not even see the more certainty. See, always there is an option to optimize. Okay, even now also we can find a better option than quantum, who knows. But yeah, we'll be more focusing, going on focusing more, focusing. We'll be improving the quality and the amount of randomness we get through other possible ways, and it ensures us the safe transfer of data, etc. Here, since it is deterministic a little bit, so we switched over to quantum number generators, which are so non-deterministic and also guaranteed by Heisenberg's uncertainty principle. Okay, let us look into this, how it is implemented and how it is used. So simply, as we saw, this technology is 100% implemented and is being used at many places worldwide. So what this does, since it is simple light, so you can you can with an electricity you can produce an laser light, so simple. That's what it is, so easy. So 24/7 you can generate a lot number of random numbers, and all are truly random. While in also throughput is so high. See, simply you can keep on generating random numbers for every photon or electron ejected, right? So you can mostly it is also a bigger number, so more number of key can be found, and more number of data can be encrypted, and like see, even though there are too many users for an application, through this method we can organize them. While in physical chaos, it will be changing for a second, it should arrive to the question. So at the end, quantum number generators are better than everything. So let us see where it is mostly applied. Mostly it is applied in financial services, like encryption during blockchain and also trading systems. Because this is high sensitive areas due to a large amount of cash transfer, right? And mainly military communications. It should be so secure that no one would no one would be able to break into the channel or hear what each other. So in order to generate an unbreakable encryption keys, we need such QRNGs, quantum random number generators, in order to help us. And mostly it is used in secure data like VPN. VPN is some places where it hides your identity and helps you do a private browsing. Also, SSLs and TLS certificates are generated using QRNGs, which will also ensure more of your safety browsing and also data transfer, encryption, decryption, etc. And mainly in critical infrastructures like telecommunications networks and because mostly national level security, and also what people talk in between, what the uh like decision taking authorities are talking in a country, nothing should be going on. So this can be used to ensure all this is happening. So with this, we can say our future is quantum secure. What do I mean by quantum secure? Since we are using quantum key generation methods, so it will help us generate lot number of keys that are never being used, etc., which will also be a big stepping stone for humankind, where the data is so secure, etc. And now QRNGs have proven that they are the best random numbers we can get now, and also the algorithms we use are so easy, and but it gives us a complex result. And main thing is the encryption and decryption process are mostly fast, and they are done in a quantum level randomness. Quantum is the most random thing you can see in the nature, as stated in Heisenberg's uncertainty principle. it can be any energy or any time the photon comes out, and the key is so different every time, and it is like something you need for a long term security, right? So whenever there is a data that needs to be stored, or there needs to be like, whenever you are contacting between someone, there is a need of true randomness. There should not be any repeating and something like, see, if you given code like generate random numbers between 1 or 2, and like I may hit you with both 1 and 2, and at a point I will get the data that is being transferred. It should not happen, right? So that's what. So simply, uh, quantum is the future for uh, cybersecurity and cryptographic algorithms and cryptographic applications. Thank you. And yeah, so finally, I'll meet you with another video next time. Thank you.